Now, we're going to talk about errors. So let's define this, and we're going to come back and talk. And the key term here we've got to make sure we understand the differences here. Sampling error is error that results from using a sample. And if you just pause there, error that results from using a sample, that's sampling error. Sampling error is error because we used a sample. Because we're taking that sample and then making an inference about a population. Remember, the whole point of the course, we're taking a sample and using that to make an inference on the population, but no sample perfectly estimates a population. So we have to understand just from the baseline that while that's the whole point of the course, you're never going to hit the nail directly on the head, right? We're going to be close. And that's sometimes what statistics is a discipline of. It's close enough. That's what we're talking about here. This isn't calculus. This isn't engineering. This isn't building a bridge, right? Building a bridge, I don't want to be close enough. I need to be dead on. But in statistics, the whole point is I can't be dead on. It's impossible. I can't actually talk to every person in a country, in a state, whatever. So I have to just be close enough and say that's going to be good enough. But the idea is that we have to understand fundamentally that we will be off a little bit. We will never be perfect in statistics. That's okay. Statistics is what we're going to focus on, is trying to quantify how much we're off by. And we're going to be off by a little bit simply because we're using a sample, and samples aren't perfect. Okay, I hope that makes sense just from a basic general understanding. We're going to be off by a little bit. Samples are never perfect. Okay, so because we use a sample, we have what we call sampling error. Now we have non-sampling error. That's error that results from humans. It doesn't have anything to do with sampling. Okay, and it usually cannot be quantified, and that right there is the problem. Okay, sampling error, and this is this is going to sound weird, all right? So I want to spend some time here because this can be a confusing topic. Sampling error is okay, and you say, well, why is the error okay? It's okay because there's nothing we can do about it, and we can quantify it. We'll cover that much later in the course, but we can quantify the sampling error. That's the idea that samples aren't perfect, so we can come back and quantify and say we think we're off by about we could be off, not we think we could be off by this much because samples are never perfect. Non-sampling error is error that has nothing to do with the fact that we used a sample, because that's just a given. That's just life, right? Non-sampling error is sampling that comes from humans, and it cannot be quantified. And we want to eliminate non-sampling error as much as possible, because if we can't quantify it, that's a problem. Let me just give you a quick example. If you hired me to tell me how much your small business might make one year, and I were to come back to you and I would say, I think your small business is going to profit $80,000 this year. You might say, oh, that's great. If my business makes $80,000, I could take salary for myself. I could reinvest. Great job. And then you'd say, wait a minute, but I know there might be some error because who knows, exactly how you're going to be, and how much do you think you're going to be off by? And I would say, in one case, hypothetically, let's say I can remove all of my non-sampling error and it's just sampling error, the error I can quantify. And I could say, I think you're going to be off by potentially $5,000 either direction, as in it could reasonably be 75,000, could be 85,000. You'd say, that's great, no big deal. But if we have non-sampling error that I can't quantify and I came back to you and I would say, well, there's some error that it can't be quantified, wouldn't that give you pause? You'd still say, I think it's going to make 80,000, but I'd also say, but I really don't know how much that might be off by. You'd say, well, if it's off by like 40,000, like that's good if it's off by 40,000 and now it's 120. But what if it's off by 40,000 the other way? Now your business only makes $40,000. Now you're sitting there saying, okay, now if I gotta pay myself because I gotta live, and if I'm not making more money than that, how do I reinvest and how do I make more? And you'd kind of start getting a little bit nervous, right? So if I said there's this error that I can't quantify, you'd kind of say, but that doesn't really make me feel good because I don't know what to do about this. So non-sampling error is error that doesn't come from the fact that, hey, we used a sample. It comes from humans. Now, there are lots and lots of types of non-sampling error. In this course, we're going to focus primarily on three. And this is where it gets confusing because we're going to talk about non-sampling error that comes from the type of sampling you used. So I want to say that one more time because gets really weird with sampling, non-sampling, etc. You have sampling error that's like used a sample, it's going to happen, no big deal. You have non-sampling error that's like it's human error. But the main types of non-sampling error we're going to talk about are because the sample was bad. But notice what we're talking about is the human picked the bad sample. So sampling error is samples happen. That's no big deal. Non-sampling error is human error because a human picked a poor sample. Okay. So sampling bias, again, human picked a bad sample. So sampling bias is a type of non-sampling error. Again, it's weird. That's just the terminology. If you got to watch this a couple times, don't feel bad. This is kind of weird. This is where a lot of times, like, in a live class, you get a lot of stares like, wait, what? Okay, sampling bias is not a sampling error. Sampling error is just a generic, it happens because we used a sample. Sampling bias is, again, human picked a bad sample and there's bias. Again, the English term use of the word bias. Because we picked a bad sample, it's when a specific characteristic or segment of the population is excluded or over magnified. Basically, when I sampled, I didn't get enough people of a certain age, or I got too many people of a certain age, or a certain gender, or a certain race, or of a certain educational status, whatever it may be. So sampling bias is when because again, remember we said key thing that highlight these ideas here, highlight this slide for sure. It's going to come back up over and over again throughout the rest of the year. We need to be able to say, is our sample representative? And if you come back and you say, you know what, this sample is missing or really underrepresenting a certain segment of the population or really overrepresenting a certain segment of the population, we call that sampling bias. It's a form of non-sampling error. That's really bad because when we have sampling bias, we can't quantify it, and I don't know what that means. It may not be a big deal, but it may, and we have no way of knowing, and that should put some fear into you because the whole point of this course is going to be making inferences on populations. But if I come back at the end and I say, yeah, but I don't know how much we might be off by, you'd say, well, that doesn't do me a lot of good. Okay. So the thing I want to point out with sampling bias, and maybe I should add this to the definition, but it's what a meaningful specific characteristic is excluded under overmagnified, whatever, right? If you have a sample and you say, my sample consists of 20% people with graduate degrees, but the inference in the population, let's say I know that the population actually has only 10% of people with graduate degrees. Now we've doubled the number of people with graduate degrees, but is it meaningful? Okay, so we're not going to call out sampling bias if there's some characteristic that's, too much or too little, if it doesn't matter. The question is, does it matter? So when we think about, political preferences, we know that having a graduate degree can really influence typically which party you want to vote for. So if my study had to do with who you might vote for, then I would say that's a problem, and that's sampling bias, that my sample has too many people with graduate degrees, and we've got to deal with that somehow. However, if my question had to do with how fast someone can run a 100-yard dash, that probably doesn't really matter. I have a graduate degree and I played college sports. I probably could run decently fast compared to most people, so it doesn't really matter, right? So it goes to, do you think it matters? And now notice you may disagree with what I just said. You may think it does matter, and that's some nuance, but where in this course you're going to be graded on if you justify yourself in a reasonable case. There's some cases where you could not ever claim something like that and it makes zero sense. There's some cases that you might say, I think this matters. As long as you justify yourself, that's totally acceptable. As long as you're showing good thought and you say, hey, this was excluded, this is over magnified, under magnified, whatever, and here's why I think that's a problem, good. Or you say, I don't think there is because I don't think that matters because here's why. As long as you're explaining yourself, that's totally fine. There's 3 types of non-sampling error we're going to cover. The next one's response bias. That's when the subjects respond incorrectly. You lied, you exaggerated, you forgot, or you didn't understand the question, or you were maybe intentionally misled. So sampling biases, the sample isn't very good because who is in the sample. Response bias, the sample isn't very good. Again, a human error. A human messed up on the sample because the responses were not very good. And this can work a lot of different ways, right? This could work by the person just deciding to lie or exaggerate. Maybe they just forgot, or it could be a bad question. This not understanding or being misled by the question is very important. This is a situation where if you are asking people how much money they make, what their weight is, if they drank underage, things of that nature. You have to understand that people might lie or exaggerate because they might be embarrassed by the response, or they might want to make themselves look better. If you think about most of us getting a driver's license, have to tell someone their height and their weight. Maybe we add an inch to our height. Maybe we subtract a few pounds from our weight. We want to make ourselves look better. Now, notice when the state takes your driver's license, there's an easy way to fix that. If they really needed your precise weight, what would they do? They'd put you on a scale and they'd record your weight. This goes back to what we talked about before, though. Is it meaningful? Do they care? Does the state of Texas, when they get your height and weight, do they care if you lied by an inch or by 5 pounds? The answer is no, they don't care. Well, with weight, they know people's weight change all the time. Height, if you added an inch or two, that's not why they don't care. They need that information because if you're ever, missing, you're ever wanted, right? If they need to find you, they need to have an approximation of your height. But who walks down the street and says, "Oh, that person's exactly 5'8"? Right? No one knows if someone's 5'8", 5'7", 5'9". Now, if you're 5'8" and you tell them I'm 6'2", they're going to say, "No, you're not." Right? They just need to be in the ballpark. So again, as we talked about before, with sampling bias, is it a meaningful characteristic that's misrepresented? And if it's response bias, is it something where I need the precision? I need someone not to lie or exaggerate. I need to know the exact truth. If so, you have a very simple solution to that. It's called actually take the measurement yourself. If I needed to know what everyone's weight is, I would not ask you what your weight was. I would put you on the scale. But do I need to know the exact number? Again, the state of Texas doesn't need to know your exact weight. They just kind of want to be in the ballpark. Okay, and then that last part about not understanding or being misled, that's just my little service announcement. If you do end up in the future trying to collect data, just do consult with a statistician to make sure you're asking good questions. Have lots of eyeballs on those. You may not realize that the questions you're asking are misleading. There's lots of ways that questions can be worded and arranged, and you'll get responses, and there will be some bias there. The responses will not necessarily be accurate because, again, we need our sample to be representative, and if the questions are worded such that they kind of elicit a certain response, they may not be representative of how people actually feel. And the last one is non-response bias. That's when the response rate is low. This goes back to that voluntary response sampling we talked about. And it's the idea that if you don't get a lot of responses, you just have to be a little bit concerned that you don't have good representation. If I send out 1,000 questionnaires and I get 50 back, the other 950 might feel very differently than the 50 that I got back, and I might be missing something. Again, is this the end of the world? No. It's just something that is an error that can't be quantified. So what do? If I have this, I know that it may increase my error. I can't quantify it, and I have to note it. I have to say, hey, take concern with these results because they may not be as accurate as we hoped. If we can eliminate these three things, again, non-response bias is a lot of times voluntary response sampling. If I can avoid that, response bias may happen again by asking people things rather than getting the measurements yourself, or by making sure that you have good questionnaires, right? We can kind of avoid that. Sampling bias, we just make sure that when we look at our sample that the demographics, the age, all those things match up with the target population. If we can make sure all of these are good, we can say, we don't have any non-sampling error that can't be quantified, and I'm just left with a sampling error, which is the error that we say is fine. Okay, now again, note there are lots of other types of non-sampling error. These are the only ones that we're going to touch on. So these are the ones that you want to highlight and make sure you're thinking about. We're going to leave this for about 3-4 chapters, and then we're going to come back to it, and it's going to play a big role. So we want to make sure we can come back to this and identify these types of errors.